SwayamPrabha. Digital India. Educated India.
Let's start with the first P of product design. What we'll do as we go through the format is I'll share with you a few pointers, a few questions, a few evaluation criteria for each of the 4 Ps. So let's look at the pointers or the question or the evaluation criteria for product design. So you can look at some of the questions that you should ask yourself or ask the research team or the R&D team or the brand team or the product team. Okay, have we got the problem defined in a holistic manner? Be it for the customer, be it for the country, be it for the category, keeping in mind the competition, etc. And then here are some more questions to validate your problem definition. Let me share with you a few examples which you may want to research and reflect on from across the world. So if you look at India, when Flipkart started scaling and started becoming popular about 10 years back, they faced a lot of challenges. And the key challenge was, how do you get Indians, or for that matter, US citizens or citizens around the world, to change their shopping habits from going to a physical store into an online store? Because in a physical store, you can actually feel the product, you can look at the product, you can touch the product, and then you can buy the product and pay the money. And suddenly now, everything is kind of becoming online. And if you look now years later, Amazon and Flipkart and many of these platforms or aggregators like Uber, Ola actually went and defined the problem very well. So for example, the online platforms, e-commerce platforms, offer far more items or choice than maybe a physical store. A physical store may have 10,000 items or 100,000 items, and that's the cap. But an online store can have maybe 10 million items or more. And they would have figured out that the consumer wants choice. And then the problem becomes, how do you give more choice? And then they solve the problem through assortment on their platform. If you look at more categories and more countries, Airbnb, which has a version in India called OYO, came out of the need that lots of times you don't know when you go to a new city where to stay. There are these expensive hotels. They may be too expensive or they may not have space. But at the same time, there are a lot of houses which are going empty. And then suddenly there's this aggregator model of house owners who want to let out their houses, 1 room, 2 rooms, 3 rooms, or a bungalow, and they're travelers who are willing to pay a little bit of money, not as much as a hotel, but use and stay in that room or that bungalow. And therefore Airbnb came out. And similarly with Toyota and many of these electric vehicles, they solved the problem of pollution, that diesel or petrol cars can be polluting. And then if you move into an electric vehicle or a hybrid vehicle, you can bring the pollution levels down. And that may be the problem that a country faces or a planet faces. Continuing, Bosch and certain companies came up with the concept of how do you use the Internet of Things to speed up industrial processes, which are called Industry 4.0. Because earlier, the different assembly lines or stations in an assembly line or plants, okay, were probably not talking to each other online. And suddenly with Industry 4.0 and use of IoT, Internet of Things, where devices are all connected, the whole process could become more efficient. And this started solving the problem of production efficiency. So these are some examples which would encourage you to research and reflect. Moving on, once you've defined the problem, it's good to look at the solution from the point of view of the customer on one side and from the view of the underlying technology on the other side. We're starting with the customer view or the user view. That will drive the product, form, and functionality. How does the customer see the product? And how does he use it? And what's the user interface for the product? And here are some pointers and some questions to validate your product development efforts. Moving on, here are some more pointers which you may want to look at and ask yourself as you finalize your product design. Here are some examples of quite famous products, solutions from around the world. So if you look at Ola electric scooters, which are increasingly used over the last several years, okay, these are quite simple to use and can be widely used by, for example, a lot of people who are doing deliveries for e-commerce platforms, etc. They don't have as many moving parts as, let's say, combustion-driven petrol or a diesel motorcycle or a scooter. If you go on and look at the smartphone of Apple, the iPhone, and then the others like Samsung, etc., it changed the whole form and functionality from keyboard-based phones where to press keys to communicate to touch screen. And the form and the functionality completely changed. If you look at the way games are played with PlayStations, earlier we had board games, we had outdoor games, we had indoor games, but Sony, PlayStation and others came up with where you could actually play some of those games virtually with a screen in front and a controller in your hand. And there are different kinds of controller. So you could actually use it to play cricket, you could use it to play tennis, you could play it for shooting, etc. And suddenly sports, games, entertainment move from the play field into a console with a TV. So it's still entertainment, it's still a game, but the product form and the functionality has changed. Similarly, shoes, Adidas or Nike or Reebok, they have gone up to such a level that versus just using shoes for walking, shoes have got so much of technology built in that they lend itself to competition at the highest level in the Olympics or in the World Games, and new athletic records are being created. And the same is across cricket, specialized shoes for cricket, for basketball, for volleyball, etc. Again, product form and functionality. Moving on, once you've got the form and the functionality from a user's perspective, the flip side of it is to identify the relevant technology one could deliver on the form and the functionality. And here are some pointers on the screen, and you could look at some of this question to validate your product technology. But the choice of technology is extremely important. If you choose technology which is still untested and emerging, it may be expensive or not very reliable. But at the same time, if you use technology which is earlier generation, you may very soon be outcompeted because some other competitor will come with a product, same form and same function, but with a better technology, and the customer can experience a better, faster, cheaper, a more satisfying product. So the choice of product technology is extremely important. Let's look at a few examples which you can research and reflect on. So if you look at Jio Telecom, it disrupted the India telecom sector by bringing in 4G and voice-based, internet-based voice communication, VoIP as they call it. So again, the choice of technology helped them disrupt the market. If you look at Tesla, for the electric vehicle, the choice of the battery technology helped them disrupt the earlier generation of combustion engine, petrol and diesel cars. Same with Panasonic. For energy efficient home appliances. And if you look at Siemens, they developed smart grids through use of superior technology. So be it in industrial application or consumer application, the choice of technology can help you deliver or solve a problem faster, cheaper, better, or more satisfyingly. Assuming that you've got the form and function well defined and you've underlined and you have selected the underlying technology, you still need to validate that the price cost benefit ratios are good for the user. Because you may have a great product, but if it's too expensive, you may not have too many takers for it. And on the flip side, you may have a very cheap product, but if the benefits are not good enough, again, you may not have enough takers for it. And here are some pointers to validate your price, cost, benefit ratios for the product that you have designed. At the design stage itself, here are a few, and let me show you a few more that you should consider. You should also probably look around and research different case studies, and I put a few on the screen, on how companies and research labs and researchers and R&D and brand managers actually deliver great price cost benefit ratio. So if you look at Indian companies like Infosys or TCS, etc., they have a huge value proposition based on doing great work in India to support customers who are not in India, maybe in US or Europe or Japan, etc., but maybe at lower cost. So the same digital solution or the service solution delivered in US or Europe or Japan, which are high cost markets, may have a certain price cost benefit ratio. But when you're delivering the same digital solution or the service solution over the net, over the internet, may have a different price cost benefit ratio if it's delivered out of India or Philippines or Vietnam. Same with dynamic pricing. So companies, e-commerce companies, Amazon, Flipkart, aviation companies do a lot of dynamic pricing to make sure that they're having the right kind of utilization, the right kind of revenues, but also optimizing and maximizing their margins. For example, if you look at a flight, if the flight is full, the airline will price it in a certain way. And there's only one seat left and the entire flight is full. That one seat will be priced in a certain way. which will probably be very high. But if the same flight is going half full, the cost will be much lower because the plane, whether it's full or half full, still has to travel. The costs are more or less the same. So the more passengers that you put in to a flight which is probably half empty, the more margins, incremental margins can you make because the plane still has to fly. And therefore, the dynamic pricing that aviation, etc., will be doing will be that if there's only one flight left, one ticket left, one seat left in a flight, the pricing will be one. That's dynamic pricing. Pricing may be high. But if the flight is not going full, the prices may immediately fall. And that's dynamic pricing. Same with companies, consumer companies like Canon or any other companies. They're always optimizing their prices to get that ratio correct. With that, we have looked at some of the drivers from the design perspective. Now let's start looking at from the production perspective, assuming that you've got the design right. The first step, once you've got the design right, is around building prototypes. Not just one prototype, but multiple rounds of prototyping, which you're testing with the customer for quality, for usage, for feedback, and so on. This is when the product starts becoming real. And I put on the screen some of the questions which you can use to validate whether your prototype is connecting with the customer and delivering and the right price point what it's supposed to deliver. And here are some more points and validation questions that you can use as you're doing a prototype testing. I'm also going to share a few examples of how different companies, before they go to market, do a lot of testing of the prototypes. For example, if you look at any of the payment gateways, Paytm for example, they will do a lot of testing prototypes and multiple versions to make sure that the product is functional, it's easy to use, is compliant with the laws of the land, because fintech is a highly regulated industry. So you do multiple rounds of prototyping. If you look at a very high-tech industry like a spacecraft, be it an Indian spacecraft or a SpaceX or a NASA or a French or a Japanese or Chinese spacecraft, they go through a lot of prototype testing before the final spacecraft is launched. Because the risk of failure is very high and the cost of failure is also very high because these are expensive machines. So these are great examples of rigorous prototype testing. And then between the rigorous fintech and then you've got the extreme examples of spacecraft, there are consumer goods which needs to be prototype tested, like a game console, Nintendo or Microsoft, and cars. Especially we're moving from one generation of cars, which is petrol or diesel, to electric vehicle. Same with BMW or Toyota or Tata Motors. So prototype testing is the first stage of when you are actually creating versions of the products. Assuming that you've got your prototype validated, certified, quality tested, it's still a few pieces of the prototype. Before you mass produce, it is also good, in fact, necessary to check that a product is serviceable, because products will have service failures, maybe 1 year later, 2 years later, 6 years later or 6 months later. When the product faces a problem, one should be able to service it. It also needs to maintain certain quality standards, different kinds of serviceability. For example, dust proof, waterproof, or water resistance. For food, it is the Food Safety Acts. For medicines and drugs and molecules, it is the FDA requirements. For physical, it will be BIS, the Bureau of Indian Standards, or different certifications. So it's producibility to quality standards and serviceability over the lifetime. And here are some pointers that I put on the screen which will help you validate and test your product, your prototype for the life and the challenges that your product may face over your lifetime of use. Let's look at a few examples. So Tata Motors in India is moving in a big way into electric vehicles, and therefore a lot of testing needs to be done to make sure that in the rigorous Indian conditions where the temperatures can really shoot up, there's a lot of heat, there's a lot of dust, the roads are not as good, there's a lot of flooding that may happen. Is the quality sufficient? And if there's a breakdown, is it serviceable in some remote part of India? And if you look at different other companies, and you can choose your own, I put some names there, okay, you can look at how different companies are actually making sure that their products, before they go out to the market, are designed to last a long lifetime with occasional services, etc. Now they've got your prototype and you've checked it for producibility, serviceability, and quality. It needs to be also designed for production and assembly, because you'll be making millions of these pieces. And therefore, the steps of production also needs to be clearly defined. Even if it's a simple thing, like a bottle of beverage, the plastic, the PET bottles will probably come in small, condensed pieces which needs to be blown up. The caps needs to come in a certain way, the labels need to come in a certain way. The liquid has to be filled into the bottle in a certain way, because you're producing millions, probably billions of bottles of beverage. And these are some of the simplest products, like a soap or a shampoo, the fast-moving consumer goods, or a bar of chocolate. And then you look at the extreme examples of production assembly, like an aircraft or a fighter aircraft, 5th generation fighter aircraft, or a spacecraft, or a main battle tank, or a submarine, or an aircraft carrier. So whether it's a simple soap or it's an aircraft carrier, one needs to take into account the production and the assembly, which in the case of a soap or a shampoo may be in billions, but in an aircraft carrier, it may be just one over a decade, because it'll probably take 10 years to build one aircraft carrier. And if you're making aeroplanes, it may take 1 or 2 months to make a top-notch fighter aircraft. Product design perspective, product development perspective, it still needs to be validated. The production and assembly line needs to be validated to have a holistic product development methodology. And I put some more questions on the screen. Looking at the real world, I would encourage you to research and reflect on how well-known products, well-known companies actually build in producibility and assembly processes at the product development stage. For example, if you look at Intel, some of the Taiwanese chip manufacturer, they have to build in very, very high quality chip manufacturing process, fabrication processes. And you should look at how Intel or the Taiwanese semiconductor manufacturer or some of the newer Indian ones that are coming up are actually making those chips. When the COVID hit us, suddenly billions of vaccines had to be made. Whether it was an mRNA vaccine from Pfizer or Moderna or the Indians one that we did, the AstraZeneca versions, Covaxin and Covishield. I think it's worth a study on how billions of vaccine doses were produced in a time of extreme crisis. Because you have to get those vaccines to the required quality in very large numbers very quickly. And then you look at in between cases of shoes, when you're making millions of pieces of shoes with sophisticated air technology or the bounce technology, or you're making millions of cars. And how does, for a car assembly, just-in-time inventory management come in? Because you don't want lots and lots of inventory lying in the factory, taking up space, taking up money when the cars are being produced. If you've got too much inventory outside the car assembly line, it costs you a lot. But if you've got too little inventory and you run out of one single part, the assembly line stops. And then the last piece is that assuming that you've got a big success on your hands, you're solving a real problem, very scalable around the world, you've got great functionality, everybody loves your product, you've got great technology which is competitively differentiated, you've got the absolutely right price and the cost and the benefit ratios, so you're making money, you're selling a lot, you've tested your prototype, you can produce it in large numbers, and then you want to expand globally. So it's no longer just an India plant, no longer just a Japan plant or a US plant. You have to build plants around the world. So how do you scale? And that's probably the last step of a successful product development process. So I put some pointers and validation questions on the screen. And here are some more that you may want to ask yourself if you are doing global scaling. And I'd encourage you to look around and research and reflect on real world examples. And I put some on the screen. For example, food delivery services. In India, we've got Swiggy, Zomato, and others. They're delivering hundreds of thousands of food from thousands of restaurants to maybe hundreds of thousands of households every day. So that's huge amount of scaling. And it's very sensitive scaling, because if you have ordered for pizza from restaurant A, you probably don't want to receive a soup from restaurant B. So in all of these, there's a quality aspects. There is huge amount of permutation combination that one needs to manage. And that's true for e-commerce deliveries or any kind of aggregator services. If you look at OTT platforms like Netflix or Amazon Prime or India, any of those Indian platforms, they have huge content. And you have to create more and more content, but you have to create the content to audience taste, and you have to serve it to the audience in a way that they want to consume. If you look at YouTube, which probably got billions of views, or you look at Facebook, or you look at Instagram, these are being consumed at the rate of billions every day. And therefore, whether it's a digital platform, whether it's a physical platform, and as you're going global, there's a huge challenge that needs to be worked through in terms of production scaling. And if you look at, for example, some of the physical examples like fashion, Uniqlo or Zara, making sure that the latest fashion is in front of the customer on time is a big challenge. And same with digital providers like SAP or Oracle, Sun, etc. So what I've done so far is try to provide you with the 8P product development framework, which starts with the problem and goes through to production scaling. Let's move on to start looking at who can use and what are the adoption and the benefits of this kind of a framework. So why should one go through this rigorous and structured framework? Let's look at some of the benefits which may appeal to all of you who are watching. So if you are faculty and working in an academic setup, it may help you to keep in mind whatever you're doing in the lab at, let's say, an early TRL, a technology readiness level 1, 2, 3 or 4. It may help bring in a culture of future readiness, which means that as the research in the lab with a technology readiness level of 3 or 4, even at the lab stage, the researchers and the laboratory keeps in mind the future glide path, the future roadmap of the endpoint, which is from the lab to the marketplace. Also, what happens is that very rarely in today's world do we have a product which is exclusively dependent on any one domain. So there is no purely electrical, purely chemical, purely civil, purely mechanical, or purely AI product. Most of the products are a combination of domains. It's interdisciplinary. And hopefully, the use of such a structured product development framework can help the researchers and the students look at the work that they're doing in class or a lab more holistically. So I put some pointers on the screen. Moving on to research labs and researchers. If there's a line of sight between the research in the lab to a pathway to the market, which means that the lab prototype, the lab technology, the lab efforts can actually have a pathway to be commercialized through products with real world use, real world need, and products then can actually be built and scaled, chances are there'll be increased interest and engagement from industry, there'll be increased funding, and there will always be a visibility into a broader world from the research and adopting the research that's in the lab. And I put some such pointers you can see for yourself. On the flip side, from academia to industry, if you're a brand manager who is a custodian of a brand, the brand may last a century. Many of the brands from Procter & Gamble or Tata Group, etc., actually last. But the underlying technology that's incorporated, or the product form itself within the brand umbrella, evolves over time. And for a brand manager to look at the brand position or the brand claim or the brand characteristics and to map it back to the product itself and how the product is supporting the brand claim, the brand position, may be of value in successful brand to product integration. And if you look at the screen, that may help a brand manager create better differentiation in the market. A brand may still be an entertainment brand and it may be competing with another entertainment brand. But if the underlying product, the underlying technology is better, is more functional, is better, cheaper, faster, from a user perspective, can be scaled better, has a better price-cost ratio, then the brand in the entertainment space with the favorable 8P rating will probably outperform a brand in the similar space, but where the 8P rating of the product, underlying product, is not as high. In industry, the flip side of brand management, of course, the R&D management, who's actually developing the product. And using a structured framework like the 8P product design and development framework will help R&D managers have a better line of sight to the real market, to the real users, and therefore drive up the efficiency of product development, drive down the cost of product development, mitigate some of the risk of failure. And as I've said right in the beginning of this lesson, the risk of failure, the rate of failure is very, very high. And with a collaborative effort between the brand and the R&D heads, using this structured framework may heighten the chances of success for this product. For leaderships, the CEOs, the CXOs, the challenge for them always is to allocate resources and create a portfolio of brands and products. And the 8P product design, which combines the external problem, the user functionality, the price cross product ratios with the producibility, the quality and the serviceability, may help develop a better portfolio of brands and products which accelerates revenues and profits. And if you look at my last lesson on 8C problem discovery, so if you combine the 8C problem discovery framework, which is to identify scalable, urgent, important, relevant, immediate problems with a very strong product development framework, may lead to better financial performance and better allocation of resources and capital. For entrepreneurs, of course, it's a must-do because entrepreneurs are always working to create a whole new category, a whole new product form, meet a whole new customer need which has not been met before. And therefore, I think for entrepreneurs to adopt the 8C problem discovery framework and then back it up with the 8P structured product development framework will heighten the chances of success and speed to market. Now, I've talked about the framework itself and some of the benefits for different academic stakeholders and industry stakeholders. Question is, how do we now drive adoption within industry and within academia of such structured frameworks? Be it the earlier 8C problem discovery, or what I've talked in this lesson about the structured product development framework. How do we drive adoption? So for faculty who see value in this kind of a structured approach, may want to build it into the curriculum, may want to build it into the way they're researching different kinds of problems, and use this as a basis of industry academia collaboration, which means have a line of sight from the work that's going on in the research lab or the department to what the company or the industry is identifying in the market and wanting from the researcher. And specifically for research labs, and this may not be in academia, it may be an independent research lab, I would offer the similar benefits accrue to the research lab. Now, the researcher and the research lab may not complete the entire 8P product development process. They may focus more on the product design side of it. But the product design, as I tried to explain earlier, needs to have a line of sight into the actual product development, the product production, the product assembly, the product quality testing, the product scaling, the product mass manufacturing. So even at the design stage, there has to be a pathway into the production side. And this is something which the research labs may want to keep in mind, especially when they're talking to industry and companies. On the flip side, as I said, brand managers can train themselves on not just how they're great custodians of the brand, but how research labs or their own R&D department or academia are actually creating great brands, great products, which the brand manager can enhance customer service and customer satisfaction with. So the brand management and the product development process can go hand in hand. And the usual training programs, workshop, etc. may drive and create a culture of great brand management with great product development. And in all of these, between academia and industry, but within industry, the collaboration between brand and R&D is key. And a common framework for collaboration between industry and academia, within industry, between the brand and the R&D management, and between the brand R&D management with the leadership who is allocating resources, etc. All of these interdependencies can use the 8C problem discovery and then the 8P product development frameworks. Because between these two frameworks, there's a line of sight between a real customer, country, category need and a real scalable, high quality product that meets that needs. And that may help in some ways improve the success of new product launches and new products that are coming to the market. And as you saw earlier in this lesson, the rate of failure right now is very, very high, even within great brands and great companies. For technology entrepreneurs, it's a must do because they're working to solve problems which have never even been identified. Forget about solving. They're probably trying to use technology which has never been used before. They're probably trying to take performance to levels of performance which has never happened before. And therefore, for them to have a framework which identifies the right problems, urgent problems, scalable problems, immediate problems, with the right product design development framework is an absolute must. And I would encourage the leadership, the CEOs and the CXOs, to start talking the language of product development in the various forums, in industry forums, or in the leadership meets, or when they're talking in their functional team meets. Because a lot of these frameworks cannot be done by any one function. It cannot be done by just marketing and brand. It cannot be done just by sales. It cannot be done just by productions or operations. It cannot be done just by quality control. It cannot be done just by R&D. It cannot be done just by finance. Because these frameworks need a collaborative view of the problem on one side and the product on the other side. And both of these are multidisciplinary within the company itself. And therefore, the leadership has to drive a collaboration across all the functions when it comes to product of the future. Finally, none of this would probably be possible without the right skills building, both on the academia as well as the industry side. So let's have a very quick look at what is the skills that academia, faculty, researchers, students, and industry, brand, or R&D, or production, or quality leaders should develop. So I've tried to capture some of the skills that academicians, be it faculty or researcher or students, should try and develop to have a broader view beyond just the technical domain. And if you look at the list that I've tried to put up, it's not just about research and critical thinking and technical expertise, but it's also about project management, collaboration across other domains, between labs, between disciplines. And if you move on, it's also a lot about communication. Because within academia, the electrical engineer probably have to talk to a mechanical. Think about a battery. It starts with metallurgy and material sciences. The battery itself has got electrical engineering, it's got chemical engineering. The battery shape has mechanical engineering. Because all the disciplines, it's probably got physics, it's got chemistry, it's got mathematics. So it's no longer just one domain. And therefore, communications, interdisciplinary communication, talking to industry, academia talking to battery makers talking to car makers talking to users of the cars. This communication chain, this collaboration chain is extremely important. And then, of course, writing proposals, analyzing, synthesizing, all of these are skills that will encourage academia to build. On the flip side is the industry skills. Because launching a product without understanding the problem, or the competition, or the customer, or the category development, or the technology evolution is the surest way to failure. So I would encourage industry and functions within that company or industry to talk to each other, Talk to academia, because in academia there's a lot of new developments that's happening, new research, fundamental research. So industry on one side should talk to the users or the potential users, but also talk to academia where a lot of fundamental research is going on, and within industry for the brand and the category and the sales and the customer facing functions to talk the production and quality and finance and research and development functions. So I put some of those skill sets on the screen, and here are some more skills, especially the cross-functional skills, and then writing great brand proposals or grant proposals where a brand manager or an R&D manager is asking for resources from senior leadership is absolutely key. So with that, I've come to the end of the lesson, and I hope you have found it useful, and I hope you have some appreciation of how to take a structured approach to product development and how this lesson about product development goes hand in hand with the lesson where I talked about problem discovery. So problem discovery and product development are both sides of the same coin. So with that, namaskar, thank you.